Hi class, let's talk about cutoff scores for a moment. You may have instances in this class where you need to determine a cutoff score to determine if a score is within the top 15% of scores or the top 20% of scores or whatever. You may also encounter this in life. So let's talk about that for a moment. If you know the mean and you know the standard deviation, there's a way that you can calculate using a formula. The formula that you would use is the formula that you would use to calculate a z-score. There's a little bit of a difference though. The formula would be z equals the number minus the mean divided by the standard deviation. Okay. And in this instance, like I said, if it's for a problem in the class, then you're probably going to know the mean, and you're probably going to know the standard deviation, and how you're going to determine the value of z is actually to look in your normal distribution table. It's in your appendices, and it looks something like this. So on this chart, you're going to look for the number that corresponds with the percentage that you want the cutoff score to be. So let's say you want the cutoff score to be in the top 20%. So you want it to be like very close to 0.20. Let's look on our chart and determine where that would fall. It looks like this number here is very close to 20%. It's 0.2019. The number on the table that corresponds with that is 0.58. Therefore, on your formula, you would fill in this number with your 0.58 that you found on the chart. Then all you would have to do is solve for the number, which we could just call x. Once you solve for x, x is actually the cutoff score. So let's say that you have a group of students and they take an exam where the mean is 100 and the standard deviation is 15. If you want to calculate a cutoff score for what scores would be in the top 20%, then you use that formula, and you would use that 0.58 that you found equals the number minus the mean divided by the standard deviation. Now, when we do this, remember back to your algebra classes, if you want to solve for x, what do we need to do here? Well, your first step would be to multiply. This would give you 8.7 equals x minus 100. Now remember, our goal is to get x by itself. So in order to do that, you would want to add 100 to both sides. This side would then cancel out so that you would have just x remaining, and x would equal 108.7. So, if x equals 108.7, that means that on that test, anyone that scored at or above this score would be scoring in the top 20% of test ranges. This makes sense when you consider what a bell curve looks like that represents a set of normally distributed data. In this instance, the mean, like we said, was 100, and the standard deviation was 15. So every 15 points, you have another standard deviation. And again, on your bell curve, you automatically know that from here, from this middle point to this mean point on, from here to here, that's already going to be 50% of your scores are falling within this range, which is average or below. Also, when you look at that and you consider the percent of scores that fall into each standard deviation, that will make sense. So again, in order to find the cutoff score, you use the formula Z equals the number minus the mean divided by the standard deviation. Normally, like I said, in your problems, you're given this, and you're given this, and in order to find this, you would look in the normal distribution table that's in your appendices. Again, you look for the number that corresponds with the percent that you're looking for. If you're looking for the top 15%, you look for 0.15. If you're looking for the top 20%, you look for 0.20. In that chart, find the corresponding number. That is what you fill that in with. You solve for X, and when you solve for X, that gives you your answer. Okay? So if that doesn't make sense, let me know. I'll try to walk you through it again, or I'll try to walk it through a little bit easier. I know that was very, very fast and a little confusing. So just please let me know if you need more info, and I will find you some more resources. Thanks.